So we don't want to just sketch the sum of two vectors or subtract them and then have just a visual representation of that. We want to actually be able to do calculations. So if we've got two forces, two ropes that are pulling on a object or something like that, we want to know what is the resulting direction in which that object is going to move thanks to those two ropes, or whatever the case might be. And so we want to be able to quantify that, and so the way that we're going to do that is by using the component form of vectors. And so in the examples that follow, we've got these two vectors that are given to us. The components are A and B. So we could sketch those out if we wanted to, and we will on some of the examples going forward. But if we're asked to add those two vectors together, then what that means is I'm just going to add together their horizontal components, so 4 plus 2, and that's going to give me my resulting I component, my horizontal component, and then I'm going to do the same thing for the two j components, the two vertical components, so 5 plus negative 6. And so that gives me a resulting vector. 4 plus 2 is 6i. 5 plus negative 6 gives me negative 1, or just negative j. And so there is my resultant vector in component form. And so then again, I can go ahead and find the magnitude and find the direction by setting up a right triangle with those components. So in this case, we won't go all the way through it, but we're going 6 in the horizontal direction, negative 1 in the vertical direction. So we'd end up with a vector that looks something like this. And so then we can use our inverse tangent to find the direction, but remembering that we're supposed to be measuring from the positive x-axis, and then use our Pythagorean theorem to find what the magnitude is. In the second example here, we're asked to find negative b in component form. So if the magnitude is supposed to be the same, but the direction is just supposed to be reversed, then all I'm going to do is just take those components and multiply them by negative 1. That's supposed to be a b there. So we've got negative 1 times 2i minus 6j. And so then we get negative 2i plus 6j is going to be our negative b. And so again, it's not too hard for us to imagine that the magnitude is going to be the same, since we can set up a Pythagorean theorem, right triangle with those two as the sides. We're going to get the same length of the hypotenuse, the same magnitude, but the direction is going to be 180 degrees opposite. If we want to find a minus b in component form, then I'm going to subtract the respective components. So I've got a and b written off to the side here just so that we can see them on the screen. So if I want a minus b, I'm going to subtract the horizontal components, the I components. So 4 minus 2i, and then we're going to subtract the vertical components, 5 minus negative 6j. And so then we end up with a resultant vector of 2i, and then 5 minus negative 6 becomes 5 plus 6, so plus 11j. So there's the difference between those two vectors. So then, as I alluded to previously, we can take these components, the resultant vector, and we can sketch that resultant vector, and then find what the magnitude and what the direction of that vector is. So with values of 2 and 11 as our horizontal and vertical components, we're going to have a vector that's oriented in the first quadrant. So we're going to travel over to up 11, so we're going to have a vector that's going up pretty steeply. We can drop a perpendicular down, so this horizontal side is 2 and this vertical side is 11. And then we can go ahead and use a little Pythagorean theorem and our inverse tangent to figure out the magnitude and the direction. So we've got the magnitude of A minus B. Remember, the double absolute value lines indicate that we are talking about the magnitude. So 2 squared, 4, plus 11 squared, 121. So the square root of 125 is 11.2 if we round off to the nearest tenth. And then for our angle, it's this angle here. So measuring from the positive x-axis, rotating counterclockwise, we get an angle measure of inverse tangent of 11 over 2 is 79.7 degrees. So again, having those components allows us to add and subtract vectors pretty easily. And then once we have the components of the resultant vector, we just go back to the same thing we did at the very beginning, Pythagorean Theorem, inverse tangent to figure out the direction. If we go to the next example here, so now we've got b minus a. We want to write b minus a in component form. So if we go back to our original a and b, so I just subtract the x components, or the I components. Oops, we want b minus a equals, so 2 minus 4 gives us negative 2i, and then negative 6 minus 5 gives us negative 11j. And again, we could have just gone back to this answer here and known that if we're reversing the order of the subtraction, that we're going to get the opposite answer. So we could just multiply everything by negative 1. So whatever approach we take, we're going to get to the same place. And now if we do the same sort of thing as we did in the previous one, find the magnitude and the direction of this opposite order subtraction, b minus a. Well, now with these two negative components, we're going to be traveling left and down. So we're going to have an angle that's in the, or a vector that's in the third quadrant. So over 2, down 11, again, roughly speaking, gives us something like this. So if we drop our perpendicular down, we already know what the magnitude of our vector is, because if this is 2 and this is 11, then we know that that's going to result in 11.2 as a magnitude. We also already know what this angle is, because that's the same as the angle that we have up here. So that angle there is 79.7, but remember, that's not the direction of this angle. We need the angle that goes from the positive x-axis rotating all the way around. So we've got to add 180 to that. So here's our magnitude of b minus a. And then if we add 180 to that, we're going to get our angle theta for this vector. The direction of this vector is 259.7 degrees.